another one of the demo days. Today we'll be going through a general flow of how a SaaS company thinks while they're building their data stack, right? So if you could be early in your journey or you could be a bit mature, we got some tips and tricks on how you should be building or optimizing for your data stack. Uh, we'll go through a brief demo of Hero towards the end, and we'll kind of go through a real life case study as well as a live demo where we try to model churn together, right? As we all know, one of the biggest problems for any SaaS subscription based company is churn. So we'll just go through one 360 view of a customer and how can you actually leverage tools like Evo or Snowflake to actually get to your end goal. So let's start with what the challenge is, right? Uh, like any company, a startup, a SaaS startup is fairly low on resources and it has a lot of data. You have so many tools you cannot manage. You have data flowing in from, like, you have some data in HubSpot, some data in Zendesk, you have somebody filing a ticket, somebody managing actually an interaction within the CRM. And then there is somebody who has product analytics within a database. And all of this exists in silos in each and every source explicitly. Generally, engineering is fairly low on bandwidth. You cannot actually prioritize these low priority tasks like building a data pipeline, managing it, and even if you somehow get somebody to build it for you, it's not going to last really long, right? It breaks, somebody changes some schema upstream, and then there is another maintenance nightmare at your hands. Then even after all of this, you build that pipeline, you got it running, it's running, and you know it's running perfectly fine. You get to the insight, but it's not as performant as you expected. So you're running about a D minus on a D minus 1 day analytics on something that you needed to know now. And even after doing all of this, you've already spent enough cost, enough money to actually paying service providers, this licensing costs, and building those pipelines. And at the end of it, you're paying for infrastructure and you're still not getting your actual business goal that you started with. So that's the general scenario for any startup, like where, or any SaaS company, not even a startup, where they have too many sources, not enough resources, and a lot of data, but everybody wants to take a data driven decision because that's the best way to actually grow. Uh, that's where the challenge begins. And that's where uh, there are three primary bottlenecks that we want to discuss. Right. One is there is data that is existing in silos. It is there across each and every uh, within departments, across departments. It's present, but it is not actually being looked at. Then even getting all of this data together, there is like it's not really standardized. It has its own problems. Cleaning itself could be a bigger challenge, and then transforming it to actually get an insight becomes a problem. And within this, you have limited resources, and then you want to scale it because the data is not going to stay really small for a very long time. It's going to grow, and it's going to grow really fast the moment you start tracking it. That's where the scale problem comes in, where you don't have enough resources to actually manage the kind of data problem that you've created at your hand. So that's where the Hero comes in, right? You have a modern data stack where you're actually uh, having all these sources which are varied in nature with different behaviors. You have something coming in from Salesforce, which is an API based source. You have something coming in from GA4, which is again API as a blob, which could be a flat file based. You could have something coming in from a database for a product analytics, product utilization. You could have something in a NoSQL database, and all of them act a bit differently with different behaviors, their own nuances, which you may or may not be aware of. And essentially, you don't want to be experts of all these actual applications that you use, right? You just want to use them for the comfort or the use case that they solve, not understand how their data works or how their data model actually works. So you bring in all of this data to your warehouse, and then you try to kind of visualize it, talk to it in some way or form today. But that's essentially what it looks like. You get to bring all of your data together into a single place, and that's where Hero fits in. It acts like that funnel that is able to actually capture each and everything and move to your data warehouse. So coming to best practices, right? Now, when you go into designing your data platform, you uh, how you really want to go ahead with it, right? So you first ask the question: do you want real time or not, right? Near real time, everybody wants some kind of real time data, right? And that's where you take the real trade off. What do you really want in real time? What do you really want in at some delay? The best thing about a platform like Evo is that it can actually support near real time processing for you out of the box. If you're trying it from scratch for the first time, it could be a pretty much long pull, and each and every source may or may not support it in the way that you're expecting it to. Then comes in, how do you actually build an architecture for a data platform? So you want to maintain each and every layer to some extent at a modular level. You want somebody to orchestrate it for you. You want somebody to actually move the data for you. You want somebody to store it. You want someone to query it, and you want someone to actually being able to actually transform it in a way that you want to, as well as somebody to add some governance layer or security layer on top of it. So, given all these components within your modern data stack, you want to adopt kind of a modular architecture where you can plug and play things a lot more easily. You're not kind of logged in. Each and every component is kind of replaceable by itself, right? So you don't want to actually burn a hole in your wallet while you're designing or trying to get an insight just from your own data. Then comes the aspect of how do you want to actually optimize for your storage and query. It's a fairly long topic. It is pretty use case specific depending on how you actually use your data. The scope changes here. So let's take two scenarios. One, if you are today uh, relying a lot on your historical data to actually derive any insight, or the other could be you're fairly uh, going to use your data every week or so, and your older data does not really matter, right? So in both of these scenarios, the approach that you take to actually store your data and how you query it changes significantly. Let's take a scenario with Snowflake where you really want to maybe add some kind of clustering if you are going to query data which is fairly large and fairly frequently. Snowflake does optimize for querying by itself significantly by auto partitioning data, and whatever is queried more often is generally like takes lesser compute to get there. But if you're going to, let's say, go through a few TB of data every day when you're going through your analytics, it makes a lot more sense for you to actually use something like clustering in place. Whereas when you are using something like BigQuery, you may or may not want to use partitioning on reads or on writes, depending on the use case. So the way you actually structure it matters is a function of how you're going to query it or how you're going to model your end product. So before you even go into a deeper design of your data warehouse, it's a very good question to ask yourself: what is the most common query that I'm going to have? What's the most common kind of questions that my end users are going to have? Uh, then comes the automation of data and governance and security, right? So everybody is kind of under scrutiny with whenever they are dealing with data. Who has access to it? What kind of access do you have to it? When did they last access it? And there are a number of things that are required for audit, for compliance, and anybody who's purchasing anything that is actually interacting with data comes in with a lot of checks that are you compliant with the relevant certifications or not. So that's where the relevant tooling is very important. So if you're looking at an ETL tool or any other uh, vendor, you need to check if they're HIPAA or GDPR compliant as we are. Or there could be a scenario where you want to actually put some kind of access controls on top of who is able to do what. So you're looking for tools which can actually handle role-based access and give you that governance layer so that you can control who can act in whatever way on whichever platform. Next comes optimizing costs, right? So uh, the whole thing is, as I said, does not really need to burn a hole in your pocket. What you're trying to do is essentially build something which is scalable, which is controllable within costs. You can actually predict your overall monthly bill of each and every tool that you're using, right? So it is part of the tool, it is part of your compute, it is also how you're going to how your data grows. Your actual cost growth is not going to be linear, but rather kind of log kind of curve where things are growing, the cost is growing a lot less substantially while your data grows linearly or exponentially. Right. So that's how you would imagine each and every tooling out there while you're doing it. For this, one of the best things is to actually decide how much of data you want to move. Uh, Generally, the tendency, given the storage being cheap, you can take a call to move a lot of data in S3 in the short term, and also figure out in the long run how do you really want to optimize for everything in else in, right? So you can use initially a object store where you want to park your data, kind of have a medallion architecture, which can significantly reduce your initial costs while you're building a data platform, and slowly figure out what actually moves to the warehouse or not. In the meantime, you can build temporary analytics on top of it if that is another layer that you're looking for. But if you're looking for something that requires long time archival or just storage, and it's not going to really be queried very often, S3 acts as a great intermittent layer or any other object store. So while you're using Evo, you do get this kind of flexibility as well, right? Where you can actually initially park some of your data in S3. We use it internally as well, where we stage and within our architecture. But essentially, what we are trying to say is that while you're trying to optimize your costs, you do need to try to optimize how you configure your ETL pipelines, because a lot of it actually goes in moving the data, and the next part goes in actually transforming it. And the last is like leveraging these advanced analytics capabilities, right? So there is a lot that has moved on since last few years, where you're able to actually configure models which are able to predict uh, give you predictive analytics out of the box. There are pre-built models on a lot of these baseline baseline schemas that are present from all these various SaaS sources, which you can leverage to actually get an insight really fast. So the time from the data delivery to insight has reduced significantly, where you actually don't need to go into a lot of depth of understanding what the source did, but rather you can actually reach to a place where it can start offering you value. So we'll take one such example as we go through the demo. So as we go through each and every bit, right? So when you're optimizing your pipelines for scalability and cost efficiency, what you're trying to do is that uh, you want your pipelines to essentially be built and not being looked upon over a period of time. You're trying to get something that is consistently running and is automated in nature. And it also essentially fits in where it is able to handle any kind of transformations or uh, changes in between, right? Uh, we do support something like CDC based uh, change data capture capabilities for near real time data movement, where we allow you to actually move your data from a database uh, to actually your warehouse in fairly low latency. Then comes on how we manage it, right? So we use fairly efficient ways to actually load this data within Snowflake or Redshift or BigQuery, while we utilize the most optimal strategy on how to merge this data into the warehouse, where we use the least amount of possible credits for a fairly large volume of data itself. Further, we also assist you in, let's say, how do you configure it, how you stage it, what kind of errors do we configure while actually moving the data by default itself. So the overall costs are under control always. Uh, with this, we move to the case study with Clean. So Clean is a fairly large subscriber management platform, uh, which helps OTT uh, services in managing their subscriptions, right? So They're used by really large companies like NFL, Optus, NHL, Weather Channel. They are fairly known in their ecosystem, and they generally help these people improve the subscriber life cycle or maximize their ROI on it. So what they're trying to do is finding the people who are actually going to pay the most, or how do you ensure there's a high retention for people who are actually subscribed to these channels. So essentially controlling churn or increasing the possible revenue for or area of growth for these people. Uh, so Kling, when they came in, they had a fairly significant challenge at their hand. One of the challenges that they had was that they had a lot of data that was coming in at a fairly high volume, and they needed to unify it. It was a multi-tenant architecture at their end. Data was coming in from different regions, different pipes, different geographies, and they needed to put it together in a single place. Essentially, they reached a conclusion that Snowflake is that destination, and they needed a solution to do it as they were not able to handle it at their end. They needed a kind of central layer, and their need for data is of a very well-defined SLA, that they need that data within 15 to 20 minutes for them to take calls. And this essentially blows up even further during when some major event happens, right? So when Super Bowl happens, they kind of go into haywire because NFL is pretty much on there. And they need that data, what is happening in pretty much as near real time as possible. So they were using this to actually feed it into models, getting an insight. Those models were returning in pretty much insights on which users are doing what, and they were without this they were actually kind of blindsided and had a trouble predicting churn for or people who will drop off for their end customers. So what happened was they started using Evo. They moved all their pipelines, a bunch of them from in-house to Evo, and they pretty much achieved fairly significant improvement in their ability to forecast churn. They improved their time to insight significantly, where it was taking about an hour to about a few minutes. And they were able to actually build the dashboards that they were looking for and have a fairly fast processing time where they were able to get all of their data in from their source systems to the warehouse. Uh, with this, we'll take a pause uh, uh, on this. We'll quickly jump into the tool itself and kind of give you a walkthrough what exists, and would love to take any questions towards the end. So that's it. So this is the main platform within Evo where you can see a bunch of sources of various type being configured, and you can actually uh, simply just click here to create a pipeline. While we go through the process, I'll walk you through each and every concept in a bit more detail. So here you get to select the source that you're looking for. Uh, I'll take Salesforce bulk API V2. In this case, I've already authorized something. So you have the option to actually add another account as well, and you get to select if it's production or sandbox. In this case, I'll just use an existing account that I configured some time back. While you're configuring this, you get to decide what is the duration that you want to bring in data for. So you have the option to control historical duration. You don't want any historical data, or you can bring in all possible data as well, right? Further, you also get to control if what happens if you want newer tables to actually come in or not. In Salesforce, a lot of times people have these custom tables. We do support custom objects, formula fields, and all kinds of underlying nuances that Salesforce has. Pretty much the whole readable object set. Further, we also use bulk API V2 in this case. Um, Specifically, sorry, I kind of jumped a few steps there. So once I've configured the source, I have the option to actually select the objects, right? So you get a full list of objects that you want to select. If you don't want to select anything or you want to remove anything, you can pretty much take that call upfront. And those objects will not be ingested itself. So they are never entering Hivo's ecosystem at all. We are not querying it, and we move forward from there. Uh, After that, you get the option to actually configure a destination. In this case, you can actually use a pre-configured destination, or you can add a new one at any time. And while you do this, let's assume I am using an existing one. Uh, Generally, the setup takes a few queries, as well as currently Snowflake has moved to a key-based authentication. So we need to create a key, store it, add it as a user while I do that. So instead of going through the whole flow, I've just configured. It's a fairly easy process. Once I reach this stage, you get the option on what kind of prefix do you want to give this table. So with every table that we create, we add this very specific prefix. So let's call it demo day. And let's assume that we want this data to move every 30 minutes. We'll quickly cover auto mapping as well in a bit more detail as we click on continue and the final pipeline gets created. So while the pipeline is getting created and moves that data in, we saw something called as auto mapping there. What auto mapping means is that you can actually create a pipeline where we fetch this data, right? And you get the option to actually give me 1 second. I'll just go to something else. Yeah. So and what happens with auto mapping is that you get this fields all the possible uh, all the possible types from source, and we automatically map it to the best possible type within the destination. We do it automatically, and it actually handles for any kind of schema evolution over a period of time. So let's say something started as a varchar initially and could eventually evolve to a JSON, or the other way around. Let's say something started as a integer, could evolve into a decimal type. All of this complexity is something that we take care of automatically. So the schema mapping layer pretty much is a intelligent engine which reads whatever happens at source and then accordingly changes it within the destination and takes it up there. So this way you can build up pretty much any source out there. We have a catalog of over 150 sources with varying from CRMs to pretty complex databases, as well as ads and analytics based sources where uh, things change a lot more frequently or a lot more dynamically. While this pipeline loads, we can quickly jump into something called as models, and I just scheduled something some time back. So uh, there are some like sample tables that we moved initially and essentially created kind of a churn model. So with Hivo, you can actually configure the whole data ecosystem that you would like, right? So you can one layer is that you get to pretty much configure the pipeline, how the data moves from point A to B. The next layer is that you can also control how it transforms. So you get the option to have a post load as well as a preload transformation. The post load transformations are comes in two flavors. You can have a DBT based transformation or a SQL based transformation. In this case, we are going through a DBT based SQL based transform, where a simple query to actually build a customer 360 across all my different tables that we had populated and moved by Hivo, and then eventually come to a eventual state, right, to see what actually happened with these customers. So that's the journey that you get to cover. Build all these pipelines. Once you've built them, you can actually configure a model which will run once the load is done within these tables. And once the load is done, the model gets triggered, the model triggers and actually creates a table within the destination. And that can actually, let's say, give you the actual utilization somewhere, right? It can be directly visualized within your visualization tool, or can be built on, let's say, you can use anything like Tableau or Looker on top of it to actually visualize something like this. So that's the end state that we achieve. In between, you also have the option to have something like a transformation layer. Sorry, let me. Well, so what transformation here means is that you can actually change anything. It's a Python-based transform where during the pipeline you can uh, let me just select an event type. So, oh, I think something went wrong. Uh, so you can actually write a Python script to modify any record, parse some JSON, or in certain cases, add a default field as well. So all of this allows you to gives you fairly good control on how the data loads. Further on top of it, you can have some kind of manual control on the tables that get created in your warehouse as well. So let's say I disable auto mapping for a particular table, and I can edit it in the way or form, like which particular uh, column does it map to within that table. I can even edit the uh, very specific table it gets mapped to. I can modify it, create a new table map altogether, and control how this data is loaded. If it needs to honor a particular sort or distribution key in case of Redshift, in case of uh, Snowflake, if we want to give a clustering key, as well as change the ordering in any way or form of these columns. So you get the ordinal position control, you get the control on which particular column it is it going itself or not, how is it named, I can rename it. So a fairly flexible capability to how you want to change things within the pipeline, and that's what makes it special or pretty much easy to use. Coming back to the actual model, right? So while I was, that's the final output of the model. We can quickly go through this and maybe take any queries or questions post that. So in this case, we brought in data from Zendesk, HubSpot, and Stripe specifically, where we create some dummy companies and their contacts and try to see if they actually had any tickets before they churned or not, right? When did they actually onboard the life of that customer? If they had any tickets open or not, if they had any negative sentiment score within the Zendesk or not, when was the last ticket actually opened, uh, when was the last payment done by them, when was it due, and in this case, pretty much nothing happened, but the customer actually still churned, right? And that's pretty much most of the time that happens. You try to go into it and then you find that, okay, there were no actual interactions. Maybe that is why the customer eventually churned. And that's the kind of insight that you get to see, that when did you actually last speak to the customer since, and what did actually happen. So that's it for the demo, folks. Would love to take any questions, queries, anything you would like to touch up on within Hivo or outside while you're building your data platform. Happy to take that.
Awesome. Thank you so much, Arav, for a quick walkthrough and probably setting up the context as well, that how a company can start building their data pipelines or even start building their SaaS data stack. Thank you so much for everybody who attended. Thank you so much, Arav, for giving us your time and a quick demo as well. We'll be looking forward to see you all again. Thank you.
Thank you.